Graph Theory Class 10 Video 2. In this video we're going to continue talking about colouring graphs. In particular we're going to talk about this notion of the chromatic number of a graph. So let's begin with the definition of a chromatic number. The chromatic number of a graph is just the minimum number of colours needed to properly colour it. Okay, so it's a very simple definition and it's quite an intuitive definition. Last time we spoke about what a proper colouring is, and if you recall, a proper colouring is where you colour the vertices so that no two vertices of the same colour are connected by an edge. And you can always do this for a graph because there are infinitely many colours, so you can keep using new colours. But the chromatic number sort of asks the question, well, what's the fewest number of colours you need to properly colour the graph? And that's the chromatic number of the graph. So let's just do a really quick example. If I draw a graph which we looked at in the previous video, this graph right here. Well, I could colour this graph as follows. Okay, so I could colour it like this. This is a proper 4 colouring. Okay, but it's pretty straightforward to see that in fact you can colour this with fewer colours. Like this vertex and this vertex don't actually have to be a different colour. They could have been the same colour. So I could have coloured it like this, which is a proper 3 colouring. Okay, and now the claim is that it's impossible to colour it with fewer than 3 colours. Okay, that's my claim. The claim is it's impossible to colour it with fewer than 3 colours. So this means that the chromatic number equals 3. 3 is the fewest number of colours needed to properly colour this graph. Okay, and I think because this graph is so simple, it's relatively easy to convince yourself that this claim is true, right? It's a really simple graph, and if you think about it for a minute, you'll realize that it's impossible to color this with just 2 colors. Okay, so the chromatic number is 3. Now let's talk about maybe the chromatic number of some special graphs. So I'm going to start a theorem, and this theorem just says it tells you the chromatic number of a complete graph. So the chromatic number of the complete graph on n vertices, which we use the notation Kn, is n. Okay, so why would this be true? Well, I don't really want to go into too much of a formal proof, but I'll just give you some sort of reasoning for why it's true. Okay, if you think about it, Kn, every vertex is connected to every other vertex. Okay, so every vertex has to be a different color. Okay, and there are n vertices, so that means you need n different colors. That's essentially the proof. Okay, that's essentially the proof. So the chromatic number of Kn is n, which makes sense because if you just even think about a couple small examples, this is K3, and you obviously need 3 different colors to color this. Okay, and similarly, if you look at K4, you need 4 different colors to color this. So that's the chromatic number of complete graphs. In general, it's very difficult to calculate the chromatic number of a graph. And if you think about it, the reason is because it's hard to know that you found the most efficient way of coloring. You might find a proper coloring, which you think is pretty efficient. But in general, how do you know that there's not like a more efficient way of doing it, which you haven't thought about yet? So proving that you found the minimum number of colors needed in general is very difficult, especially if the graph is big. If the graph is small, like this graph up here, then I think it's pretty straightforward to believe that this has chromatic number 3. But if you're dealing with a big graph, then it gets much more difficult. In the next video, we'll talk about how to prove the chromatic number is what it is in certain situations. But that's it for this video.